A 95-kilogram half-bag makes a turn on a football field. The half-bag sweeps out a pad that is a portion of a circle with a radius of 12 meters. The half-bag makes a quarter of a turn around the circle in 2.1 seconds. Determine the speed, acceleration, and net force acting upon the half-bag. So first to solve this problem, I underlined and noted everything that I was given into the problem, and then I noted what I had to find. Well, I already know the mass of the halfback, 95 kilograms. I know the radius that he takes up is 12 meters. And I also made note of the fact that he makes a quarter, he covers a quarter of the circumference in 2.1 seconds. But I need the velocity, acceleration, and the net force of the halfback. So to find these, to find the answer to these questions, you can't find one without the other. So I first tried to have the, first you went and found the velocity, which is this equation. And for D, I noted that he took up a quarter of a circumference in 2.1 seconds. So I plugged in point I plugged in 0.25 times 2 pi r. 2 pi r also is a full rotation. Is considered a full rotation of a circle. So I'm just simply typing this way, I'm noting that he took up a quarter of circumference instead of just a full rotation. So I took that and I divided 0.25 times 2 times pi, which is 3.14, times the radius, which is 12 meters, and divided 2.1 seconds into that to get that the velocity is 8.97 meters per second. So that answers the first missing variable that we needed to know. Now, now what needs to be found is the acceleration. And the acceleration formula is the velocity squared over the radius. Well, I found the velocity in the original equation, so I simply plug this into that equation, to the acceleration equation, and 8.97 meters per second squared divided by 12 meters, which goes into 80.5 meters per second seconds squared, 80.5 meters squared over second squared over 12 meters over 12 meters, which gives me that answer of 6.71 meters per second squared, because these meters right here cancel out, which leaves me with just 1 meter, so meters per second squared. So now that I found the acceleration, I can now go to the find the net force, and the net force, which we were taught, is just simply F equals m times the acceleration, or a. So since I already know the mass of the halfback, I just simply plug in 95 kilograms, and I just found acceleration up here. So I plug in 6.71 meters per second squared, and that gives me that the halfback's net force was 637 newtons.